Cool. All right. Let me know if you can't see this for any reason. And I'm going to try and have chat up in a different window at the same time. So if you have questions, I will do my best to see them and answer them. So yeah, thank you everyone for attending. I'm really excited to share a lot of cool stuff with you today. So yeah, I'm Sam, co-founder and CTO at Oso. And where this talk comes from is, it's about maybe like a decade and plus ago. I've been programming for a little while, but I'd never actually built a web app. I'd mostly done maths things, systems things, stuff like that. I hadn't built a web app. And I had a friend who had like a business idea and wanted to build it together. So I went and learned how to do web development. And to do that, I found this amazing tutorial called Rails for Zombies. It was basically about how to build Twitter for zombies. And it had this like amazing screenshot of like Twitter in the early days and things like that. And it kind of taught me about all of these like fundamental like web dev concepts like CRUD and MVC. And one thing that kind of like hit me was like, this is really what you get from using Rails. It's like actually kind of in the name. The whole point of being like on Rails is that it's giving you this really opinionated model of how to build web apps. At the same time, though, like Rails wouldn't have been such a success at like giant companies like GitHub, Intercom, Shopify, if it was like overly constraining and you couldn't do all the custom stuff they had to. Like each of those apps have their own set of requirements and specialities, things you need to do. But Rails is also like very flexible. You can do, you can use Ruby, you can kind of write anything, you can extend it yourself, and so on and so on. So this kind of brings me back to this like horrible DALL-E AI image of this like enlightened programmer sitting on top of some Rails. Like the reason I'm talking about all this stuff, like why Rails? Well, it's like MVC and things like that. They've become like a core part of my like inner programmer. To this day, when I go and build anything like web dev related, I still have that like Rails model of MVC in my head. And that's what this talk is about. Basically, at Oso, we want to do the same for authorization, right? Today, authorization is entirely missing these mental models. There's not really many frameworks. There's no like accepted models. We have like things like RBAC and ABAC that aren't helpful. And so we want to address that. And that's what I'm going to talk about in this talk. So in honor of that original Rails tutorial that I followed, my example app is going to be a project management application for zombies. Okay. So at Oso, you'll hear us talk about these three things a lot: logic, data, and enforcement. These are kind of like the three core pillars of authorization, right? This is like our MVC, but for authorization. And this little snippet of Ruby code contains all three of them. Right, so maybe the use case says that you want, users can only create tasks if they're an admin, and otherwise you want to like return an error. And so within that, right, we have these three things. There's the logic that says only admins can create tasks. This is like your core authorization logic. It's like your abstract model of who can do what. The data piece is like the concrete part, right? Is this specific user actually an admin or not, right? It might be like an attribute on the field. It might live in the database, things like that. And so like logic and data together, they give you what we call a decision. And in this case, it's like a true false. And enforcement is what you do with that decision, right? So if the user is not allowed, if the result is like false, then we want to raise an error and maybe return an error message. And enforcement can mean like all kinds of different things, like filtering databases, returning information to the UI, so on and so on. Okay, so that's logic, data, and enforcement. And I'll like talk about each of those in turn. Okay, so again, like logic, right? It's like the kind of core model of your application. It's like who can do what inside your app. And like most people, when they think about logic, talk about these things RBAC and ABAC, role-based access control, attribute-based access control. These two terms, they're kind of like, they're both so broad, they're sort of meaningless, right? Like RBAC itself, roles can be anything from the kind of UI that you see everything with like a admin member toggle, like all the way to like Azure's fully customizable roles, right? These are both kinds of roles, and there's like giant spectrum of complexity on them. Well, like ABAC, attribute-based access control, just kind of means like, oh, absolutely everything. Everything could be an attribute. And so one of the things we're trying to do at Oso is like define better terms for these things. I'm not going to go through all of these, but like here are some of the ways we've been breaking them up. We think about like roles being maybe like specific to a resource. And like once you have these more specific terms, you can start building those into your products. And so, for example, at Oso, we've like been building, resource specific roles as a core and a very, very common feature that people use. And so this lets you define things like, a user can create a task on a project if they have a role for that specific project, right? And so you might have multiple projects that belong to orgs and things like that. And the roles are not just like applying everything, they apply to like the one resource, the one project. And so we have a built-in pattern for that. And then, there's another pattern we have called like groups. And we can say, well, like, look, if you want groups, here's how you build groups. And so like, this is kind of like the first core thing we're trying to do is like, define those like core patterns. Right, and, the logic is a problem, and then define patterns that exist, and then like give people like opinionated ways to use those. But again, like if all you could do is only the things that we anticipated, you might get like 80–90% of your use case, and then maybe you get stuck. And then if you have to go do something else, then like it can really be painful. And so like, in OSO we have like with this full policy language called Polar that like allows you to pretty much express anything. So maybe users can kill tasks if the task is like entered a zombie state, and you can write some custom logic for that. So kind of the TLDR of logic is like, you want it to be opinionated so that it's like super easy to get started, and like you can just like drop in patterns from the beginning, but like flexible enough to cover everything you need. Okay, cool. So moving on to data. So again, data is like the concrete piece. Like, Zombie Derek is an admin of the organization Zombie Bears or something like that. And like one of the interesting or challenging parts of like the data piece is that data can be split across like multiple services. You might have a project service and a calendar service, and each of these have their own ways of storing and construing data. And so you need like an opinionated model that can bring all these different kinds of data together. In OSO, we call that thing a fact. It says like, it says things like, again, like user Derek has the role admin on the org Zombie Bears. And the data format is actually pretty simple here. It's like, if you express this in JSON, it's like facts have names, like has role, and then a bunch of arguments, and there could be multiple of them. So it's very simple. It's easy for like all those services to speak that format. But like making something that's like a simple data format is one thing, but like the real thing you need for like an opinionated data model for authorization is really about like performance. So like in practice, authorization policies get super big. You're not supposed to try and be able to read this, right? But like to say, can a user like read a task, you might have like 4 different ways, right? Like they might be a member on the project, they might be an admin on the project, they might be the owner of the task, they might be the task might be public. We've got like all these different ways someone might have access. And so the challenge is like, if all these different things rely on different pieces of data, how do you make it fast? And so one thing you can do, so like the way this works in like OSO is we kind of break these things down. So if you have like a piece of logic that says you can read if you're a, if you're a member on the project it belongs to, we sort of like peel out we sort of identify the piece of data you need. So it might be that so the piece of data inside this is that you need to be a member of some project and the task needs to belong to that project. Those are the 2 facts that would make that statement true. And then kind of like under the hood, like what OSO is doing is like turning this into very efficient like data lookups. So we basically have like an embedded SQLite database, and like those lookups are just hitting an index. Cool. Oh yeah, and this is what like in practice means that we can respond to most like authorization policies in like single-digit milliseconds. But again, like we need that flexibility of being able to like cover all the use cases, and like facts is actually a really nice like flexible format where we can capture anything from like roles, relationships to attributes, and things with strings and numbers and booleans and stuff like that. All right, so data, making it opinionated so you can do it across multiple services and make it fast, but we still need that like use case coverage. Finally, on the enforcement side of things, again, that's kind of the logic where, we just had like an if statement and returned an error. And that's kind of like where most people start out with enforcement. They just write like an if statement. Nothing wrong to get started, but like over time, you end up with like tons of these if statements. And if you want to go and change something, it's like really painful. And so kind of what you need is like a single opinionated interface for enforcement. In OSO, we just say, authorize takes in a user like an action and a resource. So for example, user can read a task, can they edit a task, can they delete a task? It's all just like one API. Okay, not quite one API because as I mentioned at the beginning, there's like multiple kinds of enforcement you need. And so we have like variations of authorize. You can not just ask like, can a user read a task, but also like, what are all the permissions a user has on a task, or like, what are all the tasks a user can read? And so these are the kind of APIs you like need to support for authorization. Once you have that in place, though, the thing that's really nice is that you sort of have a centralized authorization system, whether like in code or across multiple services. What it gives you is this like one API that everything's hitting and allows you to do like a bunch of really cool stuff. Right now, authorization is all going through one common place. You can like log everything that happens. You can like debug in one place, like, okay, why is this particular request like failing or not? You can do like centralized testing because you know like you have like one place where authorization is going to happen. So that's pretty cool. So I'm pretty much up on time. It's going to wrap up quickly. Again, enforcement, like the opinionated piece gives you that like one API to call everywhere, which like unlocks a ton of extra stuff you can do in authorization. But you need it to support like a bunch of different things. So yeah, that's kind of the logic data enforce in kind of like 10 minutes of like why you need that like opinionated piece and the flexibility. I would say, you know, if you would like to learn more about any of these topics, understand more like what each of these things are and how we solve them inside OSO, there are two things you could do. One is you could go and join our community Slack where, you know, we can like chat about these questions asynchronously in Slack. Or if you follow this URL, which we'll share out in Slack and as a follow-up email, you can just like book an event, like a Zoom call directly with us, and we'll chat about it. Oh, cool. And Erin's pasting the links, so you don't even need to like try and write these down in the Zoom chat. All right, so that's everything I wanted to cover. If people have any questions or things, we will have like a Q&A session later on where you can bring them up. And you know, at that point, I'm going to pass it on to my colleague Jed, who's going to do some polar puzzles, polar logic puzzles.
Yeah, we're going to talk about some polar stuff. That's cool. Share my screen here. All right, let me know if you can see that. Good to go?
Yep.
Okay. All right. Hi, everybody. I'm joining you from Portland, Oregon. I have Mount Hood behind me. It's a dreary day out as usual. It's pretty cold in my basement right now, but I have a lot of energy, so I'm ready to go. I hope you all have energy too. We're going to talk a little bit about the basics of Polar, which is our programming language, our configuration language for authorization. So what is Polar? Let's get into it. Polar is OSO's open source configuration language. It provides opinions on ways to configure application authorization service to make authorization decisions. Polar is also a declarative language, which you probably already know what that means, but it means that you describe the outcome you want and the runtime interprets that into instructions. Polar is also really designed to be an authorization language. It's not a general purpose language. It is built for authorization. It's built to make it straightforward for developers to answer authorization questions like, is this user allowed to do this action on this resource? That is what it's for. So the first question for you, put it all together. Erin, I think you're going to drop a question out there, a poll for everybody. All right, what isn't Polar? Let's see if everybody gets it right.
This is fun. Let me know when you want to end it, Jed.
Yeah, what is not Polar? Oh, and by the way, big prize at the end if you get all these right. Kind of a lie because we can't tell who's voting for what, but all right. Looks like we have consensus almost that Polar is not a bear, literally, or in the bear family. So thank you. All right. Cool. So let's go on to the next one.
Oh, sorry, I'm a little delayed. I just shared the results.
Okay, got it. So next one. Let's talk about these things called resource blocks. So people commonly have questions about how to do resource-based authorization. We think that's because it's typically when teams reach the point of complexity with when they are tightly coupling authorization logic in their application code, and when this problem comes up, they start seeking out external solutions. So we're going to start with an example with Polar with this resource-based authorization example, and these things called resource blocks. So we saw people and trying to invent different ways to express pretty common rules for associating roles and permissions to different resources within their application. And we created this pattern called a resource block to make that actually really straightforward. Describing roles and permissions for a resource with resource blocks should be pretty easy for you to understand. I'm going to go through that really quick. You define the role name and permissions. Then you assign the permissions to the role. And so that's basically all a resource block is. It's very simple. If you did this in long form, it would actually be a lot more complicated, but we've made this pattern to make it pretty easy for you. So let's go to question number 2 about resource blocks. So what can you do with resource blocks? Can you define roles, permissions, assign permissions, all the above, or build a polar bear sculpture? Looks like everybody got the point. Okay, good. Thank you. All right, cool. So let's go into the next one. Let's talk about something a little bit more complicated, or that would be more complicated normally. Role inheritance allows you to define how one role will inherit permissions from a different role, or of a different role. Like if we wanted to add a new role called writer, we would just put in add writer to the role statement in the resource block, which is pretty straightforward. But we also need to add a permission for that, like a write permission for that. So we add a write permission to the place where you define permissions. And that's, that you could put any permission there if you wanted to. And then if you want the writer to also inherit permissions of the reader role, you just declare that the writer is also a reader, and therefore it inherits all of the reader's permissions, which makes it pretty easy for you to do this in kind of an elegant way. So question 3, in this code example I gave you, can writers read? Perfect. You all are logic programming experts, I can tell. All right, let's go on to the next one. Okay. Let's talk about relations, which are, a shortened version of the word relationships. Use relations to describe the relationship between two different things. In this case, we're saying that the folder resource, that folder resources have a common relationship called parent. That means they can either be a parent or have a parent. You can use that to describe how roles inherit permissions in this part of the resource block. And this polar basically says that a reader is able to read a folder within the parent. A writer is able to write to a folder within the parent. You don't really need to explicitly mention every child or subfolder in the hierarchy if you want to grant the user a reader role for each of these folders. You just have to say that if the reader is a reader on the parent, they're a reader on all the folders within the parent. And that's actually a pretty straightforward way to handle like a recursion use case. So, question number 4. What part of Polar allows you to describe the relationship between resources, bears, beets, Battlestar Galactica, or relations? I'm happy that we have at least a couple of people who went with Battlestar Galactica, because that is clearly the best answer, though not the right answer. Okay, awesome. It's like everybody got the point there. All righty. Okay, there's a critical element, and Sam was talking about kind of talked around this a little earlier, the idea of facts. So also makes authorization decisions based on 2 things, your rules and your data. So we just talked about a resource block as an example of how you can define fairly complex things in a pretty simple way, and that's the rules. And then facts are your data. So to do that, OSO and Polar give you this concept of facts, which is a way to represent your application's authorization data. A fact is a predicate name followed by typed identifiers as arguments. And the arguments create relationships between the resources mentioned in the fact. This fact references a user, Alice, and it gives her the reader role on the folder bears. So it actually, I think you can see that it's a fairly straightforward way to connect these different ideas. So question 5, can user Claude read the folder bears? based on the code on the screen. All right, looks like most everybody is getting this one. The correct answer in this case is yes. And that's just because that's because the way the fact was written. Okay. Last thing I want to talk about is the concept of policy testing. Now, it's super important for you all to be able to test your policy logic to make sure it's doing what you want it to do. And Polar allows you to do that right inside your policy, inside your policy code. First, you give your test a name, and that's what the top part of this is for. Then you include a fact you want to use in the test. You can declare like, these are facts I want you to use while you're doing the test steps or testing the logic. And then you can test for conditions that are supposed to be true by using an assert statement, or you can use a assert not statement to test for conditions that should be false. And it's as simple as that. So last question, question 6, which of these are not elements of a policy test? Setup, assert not, or help? Awesome. Okay. Looks like everybody, for the most part, are getting it. The correct answer is help. All right. Okay. Oh, actually, this is the final question. Sorry. Final question. So, having heard about all those Polar one-on-one things, 101 things, what is Polar? Kind of no wrong answer on this one. Awesome. Okay. Yeah, so the correct answer is declarative configuration language for authorization, though it is a delicious, bubbly drink and also a cute little bear. So perfect. There is one last thing I wanted to mention. If you don't want to do this in code, if you don't want to write this on day one, there is a pretty handy little thing called the workbench, which is a part of OSO Cloud that lets you define a lot of this stuff visually. And instead of having to learn how to write Polar syntax, you can point and click your way through defining the things that exist in these resource blocks, essentially. So if that's an easier starting point for you, by all means, use the workbench. If you want to start by writing out resource blocks and using Polar syntax to write out your authorization logic, absolutely, you can do that too. And that is all I have. So thank you very much. I'll hand it back over to Sam, I think.
Yep. Cool. Thanks, Jed. So that's going to be pretty relevant for what we have up next, because I'm going to do a little demo of like looking at what all this stuff means like in action. So I'm going to go ahead and share my screen again. Okay, so basically I have a little demo app where we're going to see authorization in action. And so what I'd like you all to do is get your phones out. Actually, I guess since you're on your computers, you could also do this on your computer, actually. When I did this live, it was more fun to do it on a phone. You can either go ahead and visit this URL or pull out your phone and scan the QR code. So you can kind of watch me while you're also clicking along, or just listen. Either works. And I didn't think about how to do this where I wouldn't hide the QR code at the same time. Let me put this to one side. All right. Cool. So I can see some people starting to log in. So cool. So you visit that page, and if you're doing it on your phone, you should see a little login. Well, actually, you probably see this little get started with more DALL-E generated images. I went on a bit of an AI thing. You can hit get started into login blocks. This is not about authentication. We're doing authorization. So who cares about username and passwords? You don't need passwords. You can just click sign in or log you in as a random user. And once you do that, this might be going slowly. I don't know how many instances of this thing I deployed. Okay, cool. We got loads going. It might take some loading, but eventually what you should see is a nice list of like some organizations. And what I want you to all go and try and do is go and try and create a new organization. All right, so go click that nice big button that says create organization. And this is going to be Sam's live demo organization. And once you go and do that, and no, I'm not authorized to create organizations. That is a shame. That is a shame. My device is not showing up here on the events page. Okay, but basically what just happened is OSO just did its job for me, right? OSO protected my app and said that this thing shouldn't be allowed. So let's go. Okay, cool. Here we go. The create fails are all rolling in. People trying to create their organizations and failing. So why is this? What's going on? Well, what I can do is I can hop over to OSO and I can go and see those logs. I can see all these various things that have been denied in here, right? So Perez Cynthia tried to create an organization and it was denied. And basically what's happening, if I go and look at my OSO policy, which will define the logic for who's allowed to do what, we'll notice I sneakily commented out this line that should say that all users can create organizations. But I commented out my policy because I wanted you to see it failing. So if I go ahead and uncomment that and save my policy, right? I'm kind of in my dev mode right now. I'm like just going to live update my policy, update that authorization logic. This is now saying that any user can create an organization. So now if you go back and you try and do this again, create a new organization, trying this again, we can now see some successes coming through. So in a nutshell, that is like what OSO enables, right? We had an authorization policy that said, well, it didn't say anything. It didn't let people create organizations. And so when we did the authorization, it failed. I can now go and change that logic and my app is now updated to use it. Okay, so that was like a pretty simple example. Kind of going into like a little bit more of a deeper one. If you go into the settings page, you could actually potentially go and try and delete the organization. I'm going to try and do that now. Let's see what happens. And I get forbidden again. I'm not allowed to delete this organization. So like, what's going on? And like imagining I'm like building this app and I'm trying to figure out like why this didn't work. What I might want to do is like go to my logs page and see what's going on. In this case, I probably have too much stuff going on to be able to see that. Let's hit that refresh. Too many things. I can go to my debugging page though and be like, all right, so let's see, is user John allowed to delete organization 12 or something? And basically OSO is going to tell me whether that's possible or not. In this case, there's like actually no solutions. There's nothing that says that people are allowed to delete organizations. So what's going on? Again, I'm going to check out my policy. And again, crap, I accidentally commented out the thing that let admins delete organizations. And so this rule is a little bit different from before, right? So before we said all users can create organizations, but this one, like we just saw with Jed, is scoped inside a resource. And so this is actually saying you can delete an organization if you're an admin of that specific organization. So again, I can like update that logic. I could go back to my explain page. I could run this again. Can John delete an organization? Okay, and this time I'm seeing that there is a possibility. It says that John would need to be the admin of that organization if John's allowed to delete the thing. And so what about organization 1? Could John delete that? That one succeeded. Okay, so like now we're like understanding like, okay, so like you could, if you're an admin of the org, you can delete the org. I'm going to go back once again, try and hide my zoom bar, try and delete this and see how it goes. Cool. It's deleted. It's gone. And so that's kind of like, this is sort of the power you get from having that. Some of the things I touched upon in my talk at the beginning is like the sort of basic concept inside OSO is you have this authorization system that's like answering questions for you, like who can do what. You're configuring that like generic logic. User can create orgs, admins can delete organizations. You've got those like concrete piece of data. So when you went in and created an organization, let's see if I say user John, you can see like, for those organizations you created, we've put in a role that says maybe, John is the admin of that organization. And so between those two things, right, the policy plus that data, we're able to make that decision show up in the logs, decision comes back to the application, and the application is ultimately like deciding what to do, right? And I didn't need like redeploy my app. I didn't need to do anything like that in order to like impact the behavior. So I can just like go and extend this logic however I want. I'll kind of pause there and maybe try and catch up a little bit on the Slack and see what's in the Slack, in the Zoom rather. Let's see if any questions around the demo. Yeah, any questions on what I just showed you all? And feel free just to like unmute and share as well. Cool. All right. Well, that was the main things I wanted to share with you on my side of things. At this point, I'll pass it over to Mike, who's got a bit more of a deep dive on some of the internals behind what made OSO able to do all those things you just saw.
Cool. Thanks, Sam. So I'm just sharing my screen here. Cool. So you were promised a tech demo, and instead you have some more slides. Sorry. But I do want to kind of use this as a dumping ground, like a launch pad, to talk about some of the architecture things that we have at OSO. So what I'm going to be demoing today is really our event sourcing architecture and how it enables us to scale and maintain low latency at scale. And along the way, I'll talk about some of the rakes we had to step over in case you also have a plan to build an event sourcing architecture at your company. So before I jump into some of the kind of the overview, I'm going to take a minute to scale up something for the later part of the demo. So here we're going to show some how we are able to sustain load and maintain a low latency. So here we have a one worker doing about 50 reads per second. So I'm going to scale that up and crank it to 80. So it's going to be like 4,000. So I'm going to update that. And AWS takes a little bit to crank that up. So now we can go back. All right, cool. So the main reason we chose an event sourcing architecture is that we really wanted to optimize our read latency. So Sam has mentioned in multiple podcasts that we use an embedded database. We use SQLite, and we co-locate this database with all of our what we call feature nodes, the things that respond to authorized requests, so that we can have the fastest possible access and return a response to the user in the lowest amount of time. Internally, we target somewhere in the order of 10 milliseconds round trip. So that includes network latency. That means really from a compute perspective, we have like an upper bound of about 5 milliseconds that we're trying to hit. And what the event sourcing architecture allows us to do, it allows us to keep replicas in sync. So here, what you'll see here is that a user is going to write to one of our nodes. So here, this illustration has 3 nodes in US East 1, 3 in US East 2, 3 in US West 2. It'll write to one of our APIs. Instead of persisting directly to a database, it will instead write to a message bus. We currently use Kafka, but you can easily swap that in for Pulsar or some other sort of like message queue. What we're measuring in terms of latency is that it takes about, on the order of 50 milliseconds to write to our message bus. And then from there, it just gets distributed to all the nodes globally. So we are currently up to 10 AWS regions spanning all of the US ones, and then some in Europe as well, some in APAC. In US East, where one of our Kafka deployments is, you'll get that response back within 1 millisecond. So you're really not incurring a huge cost on the receive side of things. Cool. And yeah, I think, and then, so this is how, yeah, so that's kind of it. So let's jump to some key stats here. So we have our read latencies. So here we have P99 of about almost 3 milliseconds. This was from 2 weeks ago, from the past 2 weeks, and we had a particularly bad outlier, which made our average greater than our P99, which is kind of uncommon. And then on the write latencies, we also are, I think, pretty sufficient. We have within round trip US East to US East, we're looking at like 50 milliseconds. And then when we go cross country, we're looking at about 200 milliseconds. And then one of the nice things about our architecture is that we can spin up new nodes relatively quickly. So if we need to scale out, so I think by cranking up to 80 in our dev environment, we should need to add a few more nodes. We can spin up new nodes in about 2 seconds. And that allows us to grow relatively quickly and absorb any load that we see. So I said I'll kind of talk through some of the rates that we had to walk through. So the first lesson learned we had really was around kind of make sure the test infrastructure mirrors your event sourcing architecture. So one thing about event sourcing architecture is it's not instantaneous. So if you assume that in your test suite that all writes are instantaneous, you're going to have some really bad days when your production starts to exhibit behavior that you've never seen in your test environments. So that's kind of the first lesson we learned. The second one is really being aware of, in this case, Kafka internals. So Kafka has been designed, and they've made a lot of design decisions based on what they think are the most common use cases. The way that we're using Kafka may or may not be necessarily the primary use case that they're thinking of. And that's required us to dig into what it's doing. So in this case, rebalancing of consumer groups and thinking about how we can work with that to support our needs. And then lastly is observing everything. So this related to the Kafka internals piece is that they've made design decisions about how consumers are architected, and we don't follow all of those patterns because of our use case. So we want to make sure that when nodes are falling behind, because that's really a bad experience for a user where they'll hit one node and they'll get an allow, and they hit another node that's getting a deny because that node is not seeing the most current state of the facts. And that's pretty much all the slides. And now I can jump into the demo. Just move things around here. Cool. So so this is the UI. I don't think this has been shown yet. I think we've kind of shown some screenshots of this. So I want to show this is a policy, is one of our common policies that we have, which is it's similar to the Git Cloud, where you have an organization or repository, and you can read and have permissions on a repository either directly or based on roles that you have assigned on the organization. So I'm going to go and try to do an explain here. So user Alice, can they read a repository handle? So in this case, there's multiple ways that I think Sam kind of showed this, multiple ways that Alice can read repository handles, either having a role, having direct permission, or having a different role on the organization. So next I'm going to show, so what I have here is a local deployment, as you see, it's localhost. And because you're using Kafka, I can spin up a local environment relatively quickly. And I'm going to go and add a fact here. So what I'm going to do is make sure that Alice has a role. I'm going to use this autocomplete that we have. User Alice has a role, member on organization. Oh, this is why I don't type Acme. I'm going to add a fact here. Oh, I need to restart my service. Oh, there it is. All right, cool. All right. And see, there was a little bit of a lag there, but I don't think that's like totally perceptible. And there's other networking things that might be happening at home. And now when I go back to explain, I can now see that user Alice can read a repository. Yes, so because Alice now has a role on the organization, they can read from Anvil. And kind of just showing one more thing here. This is the Kafka stream that we have, and it shows that this fact was inserted. And this is something that every single node has access to. And then the last thing is really to see kind of how is our load test coming along. So as you can see, we went from almost no we had like 50 reads per second. We're now up to, I think, 4,000 reads per second. And we really haven't, we've actually seen our target response time drop. And this is something I think something we want to look into, but maybe also an artifact of our dev environment, and why we are seeing this in like when we have less volume. But once we scale up, we'll see that the P99 of our response time drop quite significantly down to about 7 milliseconds. In production, we do a little bit better because our production hardware is a little beefier as well. And we can also see, interestingly enough, oh yeah, there we go. And then this was how many nodes we had, when we started. And then once we cranked it up, we had to spin up the new nodes, and that happened relatively quickly. Because I think it takes longer for AWS to react to the fact that we need to spin up new nodes than it is to spin up the nodes. And we use Honeycomb to explore this, and we can see that the heat map of the distribution, I should just look at the last 10 minutes. We can see that we're kind of mostly in this kind of I can't really tell, but in a, like us, I should show over to log, because can't really see when it's regular. So it's sub 10 milliseconds as measured from the service itself. And then from there, as I mentioned, we try to deploy closer to our users, and that's why we're in multiple AWS regions, and that's how we make up the difference on the network to maintain our internal target of 10 milliseconds. That was a lot. And that's it. And then we could go over to Q&A.
Thanks, Mike. That was exciting to see live and a little scary. Glad it went well. All right, well, everyone take a second and raise your hand if you have a question. We've got some time, like 10 minutes or so. So thanks, Olu.
Aaron, it's a shy group. It's a shy group.
Yes.
Got a lot of questions.
Yes. That's okay.
Can I ask something?
Yeah.
Can you guys talk a little bit about like how you guys compile the polar language down to make the reads more efficient? Especially if it has like lots of relations and things like that.
Sure, yeah, I can try and touch that. I kind of zoomed through it earlier. So basically, let me pull up the slide again where I kind of went through that quickly. Sorry, I closed all my windows so I could get the demo up. So, okay, so the problem we're talking about, right, is you've got, you've got your authorization policy that maybe has multiple different paths that a user might get access to a thing. And like, even in this simple example, we have like, multiple different paths through, we might have like multiple different like relationships to traverse. So for example, in the case where we said like read if you're a member on a project. So what OSO is doing when it like evaluates this logic is it's basically, I think I can maybe show this even better through explain. Like if I say, can John read repository 1? So when, as it's like evaluating the logic, various parts of the logic, it will be like, that might exist in the database as a thing to check. And so it will kind of like, it constructs this kind of like almost like a constraint that's like waiting to be solved. You can kind of think of this as like a system of equations that OSO needs to solve. And so when it goes through, it's like, okay, you can read a repository if you're an admin on the organization the repository belongs to. That like repository belongs to thing. Okay, that's data that lives in the database. The user has a role in the organization. Okay, that's data that lives in the database. And so we have these kind of like pending constraints. And you can see the way that like this logic that we expose in this like debugging interface is the exact same thing the engine is doing. It's like constructed this, we need to solve these things. You'll notice we've basically tried to fill in as much of the concrete things as we can. Okay, we know it's repository 1, but we don't know what the organization is. That's like currently a variable to solve. We know it's user John, we know it's an admin, but we don't know what the organization is. We need to solve these things. And so each of these we turn into basically a SQL clause, like look up in our database. Right, so each of these facts, we like turn it into a table search, right? Where we know that the user is Derek, we know that the role is member, but we don't know what the project is. Now these tables basically have, right, all of these as columns, like the fact is called has role, like the type of the argument, the value of the argument, and so on. And so for like all but one of these columns, we actually know exactly what the value is. We know that the predicates has role, type is user, ID is Derek, type is string, ID is member, type is project. The only thing we don't know is the project ID. And so like we basically have an index, which will have index on all of the known columns and leaves that one unknown like left variable. We do the same for this other row has relation. And basically what SQL is, what SQLite is doing under the hood is like finding the intersection of those two indexes. And so this same logic applies like across like however many of these things you do. We're always just like saying, SQLite, do your job of like look up this in this index and then like look up this in this other index.
Okay, interesting. So is it like the case, like, I don't know why anybody would do this, but like if somebody created like this hierarchy that was like these like relations that were like thousands of like levels deep, that might like be really unperformant, right?
That would probably be unperformant, yes.
Okay.
Well, honestly, even then, SQLite is pretty damn good at doing those kinds of things fast.
Yeah.
Like if each of those relations only had like a small number of relations, they would actually get through this pretty quickly, honestly.
Right. Can I ask one more question?
Sure.
So you guys, then does that mean that you're running like SQLite, on the read path? Then you're running like an instance on that on like every pod or something like that, or?
Yeah, exactly.
Got it.
Yeah, so that's kind of what Mike was walking through, right? We have this like embedded database model where every node closest to, and like in all the regions, is running this like embedded SQLite database. Right. So like you're only making them one network hop to us, and like the way the problem that SQLite doesn't solve is how to get the data everywhere. Yeah, and that's what the Kafka piece is doing for us.
Yeah.
Oh, there's tons of questions. I need to read through them, or someone else could jump on some.
Yeah, why don't you take the raised hands, and then Steffi and I will make sure we get these questions in the chat.
Sure, sounds good. I think Navan, I think you're first.
Oh, that's the name of the company, I guess.
Yeah,
sorry. No problem. Thanks for the great demo, Sam. And I had a kind of more conceptual question. So for authorization, the authorization engine needs to be aware of all the entities, users, folders, doesn't matter. And I know you guys have great blog posts that talks about it, of like how make authorization engine aware of those, like depending on architecture, whether it's monolith or microservices and so on. I had a question about one particular pattern that I often see in many startups as well, is that they start from tightly coupling SQL queries with authorization. So they literally, if there is a request to get users, get me all the users that have permission to read this resource, and you can do this efficiently as long as everything lives within one database. And now when we transition, the company grows and they want to have more advanced authorization without having to implement it themselves, they use a framework like OSO. And so do you have recommendations of like how to how to make transition less painful for this particular pattern, because it's kind of hard to decouple those.
Such a good question. We're like working on like a more opinionated guide for exactly how to do that. I think like one of the things that we see being pretty useful is, so we have this concept called like called context facts that allows you to kind of still query also the policy, but like while using the data from your own database. And so like if you have like existing, maybe even like existing logic or like existing data, you can just like, you can, to begin with, just use OSO to like kind of handle the logic part of it without the data. And so that, for example, you might just have a model where you assume that your app is already handling like the multi-tenancy aspect, and all you actually care about is asking OSO like, what can a role do? That can be like a good place where you can like write a policy that uses like org specific roles and it's like built in the conceptually the way you want it to be. But you sort of like shim to tell OSO like, and just assume that I've already checked that the user is in this organization, what can they do? It allows you to kind of still use that like logic for like role permissions without like having to do like that migration up front. And there's kind of like variations of that at like every stage. You know, some people have like really complex like custom code to implement different like attribute checks. It's like some of that you might want to keep in the app and just kind of represent that in OSO as like assume the app has checked this piece for me. Can they do these things? But it's yeah, it's something we want to kind of like write up more guides for, because we see that problem a lot where people go through these like iterations of like authorization complexity, and we want to make those as smooth as possible.
Got it. Thanks. So keep an eye on your blog, I guess.
Keep it on the blog.
Thanks so much.
Thanks. Good question. Tyler.
Hey, thanks. The two questions. One, it's been, I think, about a year since I've gone through the Authorization Academy, and I was wondering if anything has like changed inside of that since, or if it's been updated recently.
We haven't actually made any big changes to Authorization Academy in like the last year, which
Cool.
I hope is a testament to the accuracy of the information there, that it's
Right,
not,
exactly.
it hasn't gone out of date.
Authorization doesn't change that much over a year, but
There's
Yeah.
one new chapter on microservices. I don't know if that was there when you looked at it last.
I think
So
it
that might be
was.
some addition.
so,
Okay, so if that was there, then you're good.
Cool.
Yeah, I will say, I was writing a blog post that was like a why authorization is hard part 2 that ended up getting very long, which I could see being like maybe the next part of Authorization Academy. Like one of the things we talk with folks a lot about is like we have this kind of idea of a data taxonomy, which is like what different kinds of data exist inside applications, what data should go inside OSO Cloud, and how do you think about those? Which I could see being like a kind of another entry that we might do in the future.
Yeah.
Yeah.
I don't know if I didn't know if there was a like any section on the docs or on the blog talking about how like dynamic roles might be created, essentially where you're able to kind of create a subset of structure how it should be, and then you kind of hand over the role creation to whoever's inside that organization. Is there a doc for that to walk through?
Yeah, so we call that custom roles. We have a short thing in our like modeling guides on how to do it, but actually one thing we do have on the roadmap is to write like a more complete doc on how to achieve that, because it's yeah, there's like a bunch of considerations in how they
Seems, yeah, it seems straightforward up front, and then you start to kind of dive down deep into it, and you gotta get yourself into trouble real fast.
Yeah, like the short version is like, you know, whereas in like with regular roles you just say like read if admin, you know, the dynamic version of that is you kind of say like a user has permission if they have a role and the role has been granted that permission, and that role has been granted permission is like the dynamic piece where a user could potentially be the one inserting that data.
Perfect. Thank you.
No name person. Hey.
Hi. Earlier you mentioned the context-based rule evaluation, like this person has rule or role A, and you evaluate that. The docs actually seem rather sparse on that concept. They're only mentioned under some ABAC thing under the tutorials section. Is there plans for more comprehensive documentation about idiomatic use of that system?
I mean, given that you bring it up, yes, is the short answer. Like, I like hearing you say it out loud. I'm like, you're right. I've also had this problem where I've wanted to link people to it and realized that there's not a good reference for it. Yes, that's a great suggestion.
One of the main things holding my organization back from moving to something like OSO Cloud is that we have an immense amount of authorization data already in the database.
Mm-hmm.
And going and telling OSO about all of it would be less than convenient. So being able to use OSO and Polar for defining like the permission side of it, like how to evaluate whether or not an admin can do writing. That's why we're currently going to use the library version, because then we can use the FFI to do our own lookup. If OSO Cloud was capable of using the context to make lookups like that, that would be a game changer.
Yeah, I agree. And I think people have kind of alluded to this in the chat, but like, that's kind of what I would love to see part of like the long-term vision of this, is where you don't need to sort of choose like either one, that kind of the two work more harmoniously together for that reason. But yeah, so like today, like where context facts is good is being able to use the logic engine without needing to store the data. It does come with like some constraints or like some trade-offs. Like, for example, you need to know what data to fetch, which sometimes can be like as complicated as the like authorization piece itself. You know, I spoke around, the SQLite indexing approach we use to make those queries efficient. Like that part's like on you. And then similarly, there's kind of like some limitations with context facts around like what kinds of questions you can ask also. And so that's why we tend to like recommend it for specific use cases where we feel good about saying like, for those use cases, you will have a good experience. And for the other ones, yeah, we need to do a better job on like saying when it's a good, documenting, as you said, like when is a good time to use them.
Okay, I'm going to close out if we are done answering questions.